Hello everybody, my name is Walter, and this is episode 8 of my Redstone Commands Series. In this episode I want to cover three things: variable types, variables, and values. First I want to talk about what the relationship between the three is and also the difference. Then I want to cover what you have available as variable types in Minecraft, and then finally I want to give you a few ideas of what you can actually use as a variable to store data within a data pack, but also could potentially be used to interact with a player that is using a specific data pack. And with that, let's start with what are types, variables, and values actually. So here I've tried to give you a rather generic description. Types are a sort of recipe or description of how a variable works. A variable is a placeholder for information that has a certain type. The type basically determines how the information that is actually in the physical memory of your computer, for example, as ones and zeros, has to be interpreted. Is this a number 1, or is it a letter Z, or is it a 0.567? Just as a few examples. So variable is a placeholder of a certain type, and the value is the actual information inside of that variable. So the series of ones and zeros, and usually interpreted according to the type of the variable. Let's give you a rather non-programming based example. Let's talk about a book. What is a book? Here I've tried to give you a list of requirements which make a bit of a description for a book. Book is something that is a series of pages, should be at least 10 pages, or it's a booklet or something like that. All of them are bound on one side. They contain words. You need to read them from top to bottom, left to right, and so on and so on. That's the description of a book. It's still nothing you can actually physically touch. This is just something that if you find an object and it fulfills more than 10 pages, bound on one side, and so on, then you know, okay, that's a book. You also know if you want to read the book, you need to open the book and start reading in a certain order. That's the type. The variable is the physical book you have in your hand. It's a placeholder, a container for the actual information. You can read it, you can touch it, you can open it. And then the words and sentences inside of that book, that is the actual value. That's the information inside of that book. And if you look at another book, there is different information in there, usually, unless it's a copy, obviously. So type, just generic description or a list of requirements. Variable, the container for the information, and the value is the information itself. In Minecraft, when we're working with commands, the types are things like floating point numbers, whole numbers, text, arrays, and so on. The variables, there are several examples, as you will see a bit later in this episode here. Those are things like scoreboard objectives, MBT data, block data, and so on. And then the actual values, well, it totally depends on the circumstances. This can be just simple text, it can be a floating point number, so an actual value like 45 degrees or whatever, 10 areas, and so on and so on. So that is what you will usually find when you're working with programs. Following that, let's talk about the different types you can actually use in Minecraft in commands. Before that, one little heads up. You will find that there are several types that describe more or less the same thing. For example, there are 4 different integer types or whole number types. The reason has to do with memory space. Part of a type description is also how much memory gets reserved for a variable of that type. A direct consequence of the amount of available memory is how big the biggest number you can actually represent is. Subsequently, the bigger the numbers you need to represent, the more memory space you need to represent or to allocate. On the other hand, the more memory is allocated to a variable, well, the more memory is used up, and also potentially the longer the processing of that variable may take. So for optimization reasons, programmers try to use the smallest type that still will fit all of the possible values you have to work with in this instance. And that's the reason why you will find, for example, 4 different types for assigned integers and 2 types for floating point numbers. Secondly, when you're, for example, looking at NBT data, you will find that after many of the values, with just a few exceptions, you will find a single letter. This letter actually tells you what type this value is of. So, for example, F stands for float and B is byte and so on. But I will show you in just a few seconds the different options you have. And that should be enough for a prologue for that part. So let's get to the signed integers or whole numbers. Those numbers are signed, which means that half of the value range is in the negative and half of the value range is in the positive. The smallest type is byte or small b, which goes from minus 128 to plus 127. 27 because the 0 counts as part of the positive range. Then we have short, which has twice as much memory space and already goes from minus 32,000 roughly to plus 32,000. Then we have int, which is the only whole number or integer type that doesn't have a number, letter. So this here would be an integer, for example, or this here would also be an integer. Integer goes from roughly minus 2 billion to plus 2 billion. And then we have even bigger a type with long, or sometimes also called long int or long integer, which has the letter L, and which goes from minus 9 quintillion to plus 9 quintillion. So a very, very big number. Scoreboard objectives are always of the long type, by the way. One thing all of these 4 types have in common is if you add 1 to a number, you get to the next bigger number. And the same is if you subtract 1. So the resolution is constant. I'm saying this because floating points deviate from that. So floating point numbers are basically done by dividing the memory space into 2 sub-numbers, you could say. The first is the mantissa, so just a factor, and then you have the exponent. So the resulting whole number, or the interpreted value, is the mantis multiplied with 10 to the power of the exponent. And you can see that you can represent very, very big numbers with that, but the further away you get from 0, so the bigger the exponent becomes, the worse your resolution becomes. And it will quickly happen that if you're adding 1 to a big number, you don't get the next bigger number, you get the same number back. So rounding errors will become worse and worse the bigger the numbers are when you're working with a floating point. That's rather important to realize here. Anyway, let's talk about the 2 types we have. The first is float, represented by an F, and this goes in the range from plus minus 3.4 to the power of 38, or 10 to the power of 38. And then we have double, which has twice the memory space allocated. Here the D is optional, so if you use in a command, for example, a 1, that would be interpreted as an integer, but the moment you put in a point, this is interpreted as a double. The D is optional. You can add it, you don't need it to add. Anyway, double goes from plus to minus, or from minus to plus 1.7 power 10, 10 to the power of 308. So very, very big number. Then we have simple Boolean, so false or true. When you're working with commands directly, you will usually find false or true as an actual value. When you're looking at NBT data, we will generally find a numeric representation, which is, since it's the smallest type, used or using the byte type. So 0b means false, 1b would mean true. So generally things like, is the entity invisible, has the armor stance, it's arm visible, is it gravity affected, is the AI active, or whatever. Then we have string, which stands for simple text. Now this can be just straightforward text with those quotation marks here and just text in the middle. Or it could be also JSON text. JSON text is something I will cover in a later episode, but essentially it's text where you can add more information, like for example a color, or is it bold, or is a command embedded in the text that gets activated when you click on it. That's what JSON text is about, but as I said, I will cover that in a later episode. Then we have lists and arrays. There are occasions where you have, for example, here the position of or the orientation of the head of an armor stand. And those are 3 values, and they all belong to the head and all describe just a different axis of the orientation. And what is done usually is you don't have a variable head axis 1 and head axis 2 and head axis 3. No, you use an array or a list, which in Minecraft are pretty much the same thing. So it starts with a rectangular bracket, ends with a rectangular bracket, and in there you have the values separated by commas. That's just what a list is. All of the values in a list need to be of exactly the same type. That's important. Arrays in Minecraft, as far as I could figure out, are pretty much the same. The only real difference is that there are only 3 types of arrays: a byte array, an integer array, and a long array. And the only difference to a list is that they have the type description and a semicolon at the beginning. The rest is the same. So I don't really see a difference besides of that. Yeah, that's essentially what this is all about. Now, when you're using commands, it's actually possible to access just a single entry in a list. So it's possible, as you will see in just a few moments, to only override this part here or only read out this part here into a variable. And when you're doing this, you have to be careful. This is using the 0 as a base. So this here would be the 0th entry, this one would be the first entry, this one here would be the second entry. That's important to realize. You will find this occasionally in programming languages, although some also start at 1. But in Minecraft, you start at a 0. That's rather important to realize here. Or you will find that you access the wrong variables. And then we have compound, which is something like this here. So the value of a NBT tag is another NBT data. So you build up a deeper hierarchy. I already showed you this in the previous episode, and yeah, there is no real surprise there. One more important thing I should mention here is, especially when you're working with NBT data, when you try, for example, to write a floating point number into a value that's actually of an integer, the value will get rounded. So values get automatically adjusted to the proper type. For example, it's also possible to write a text into a numeric value. Depending on how that happens, it may actually count how many letters are in the text, or it may just straightforward write into a 0. So it depends a bit on the situation. So this is also something you should be aware of. If applicable, it will round and adapt to the proper types. And that brings us to the last part for this episode, which is what you can easily use as a kind of variable for commands and programs and data packs in Minecraft. So let's start actually very simple. You can use blocks directly as a variable. You can place them with a setBlock command, and you can check for them using the execute if command. So here, very simple example. I click the button, nothing happens. I place a block, nothing happens. I place a very specific other block, now I get a message. And if I add more execute commands with different checks for different blocks, I can write a simple interface or create a simple interface the player can actually use to control how a data pack, for example, behaves. I've used this in the past already in my signal generator, where basically by placing down redstone blocks in certain positions, you could turn on or off the outgoing signal in a certain timed sequence. So very simple to use, very intuitive to use in a certain sense, and allows a very direct player data pack interaction. Now, you can go even beyond that and not only check for a certain block type, you can also check for block data, you can check for NBT data, not only of blocks or block entities, but also of normal entities. there are many options there. Then you can also use text as a kind of variable, although this is very limited. If you look in the NBT data of this hour stand here, you will see that there is actually tags. So I have tagged this armor stand already, and you can see tags are just straightforward text. In this case, this is called test story. And this can be used as a condition or a filter in a target selector. So here I'm checking for armor stands in a certain distance and checking for this tag here. So let's plop down a second armor stand, and you can see when I activate this here, only this armor stand here reacts. So this is a quite useful option if you're working with a data pack, for example, and you need to do different things with different armor stands. And then it's very simple to just tag the different armor stands with different tags, and subsequently have the parts of the different parts of the data pack only running on the specific armor stand they are supposed to run onto. So this can be quite powerful, but it's pretty limited if you compare it to normal programming languages where you can put text together and put variables into text and other things. There are some things you can do with JSON text, but those are rather limited. And with that, let's get to scoreboard objectives and also a bit to NBT data. So scoreboard objectives are, as I already mentioned, long integer variables you can directly use. So you need some kind of entity, or you can also use it globally, to store the information, which is quite useful if you want to do several things in parallel. Then you can use the same variable on different entities, for example. And since you can do things like plus, minus, comparisons, and similar, you can actually do basic math of that. Just remember, since you're using long integer, if you do things like division, you will get rounding errors usually. That's something to be aware of. Now, let's talk about a little trick. You can actually store or read information from a scoreboard objectives and write it into NBT data, and vice versa. This is something I have first seen used by SafBling in his Bling edit, and I find this is a very interesting concept and can be quite powerful. And can also be used, for example, to make or to shortcut advanced math. I will show you what I mean in just a few moments. But first, let's show this example here. So when you look in the NBT data of the armor stand, you will see there is a rotation tag, which is actually a list of two floating points, one for the horizontal and one for the vertical orientation. And I also have already given this armor stand here, which is named by this rather strange string of letters and numbers, already a scoreboard objective, rotation score. And I can change this rotation score. So far, so good. Now let me activate the hitbox so you can see actually things happening. So let's set this to minus 45. And now let's quickly look at what this command block here will do. We have the execute store. This allows you to store information in a score, but also in NBT data. More about the execute command in a later episode, but what is happening here is essentially I'm writing a number into the NBT data of this armor stand here, which I'm selecting via this target selector. And I'm writing it into the rotation tag. And here I am selecting for the second, remember the indexes start at 0, into the second entry of that list. This is a floating point number, and I'm giving it a scaling factor of 1.0. And the number I'm writing in here is provided by the scoreboard, which checks for, again, the score of this armor stand here and here for the rotation score. So what happens is that it will take this number and write it into this tag there. And you can see the armor stand is now looking up, or diagonally up. And if I set it to 45 degrees, the armor stand is now looking down. So I'm not directly writing a number into the NBT data. I'm indirectly writing it into the NBT data by first storing it into a score and then writing it into NBT data. Now this may seem a bit roundabout, but you can actually do powerful things with that. As I said, more in just a few seconds. Now you can do the opposing too. Again with the execute store command. This time I'm using it to write it into the score of the nearest player, so me. I'm giving myself also the rotation score, and the value I'm writing in there I get from the data get command. And here, once more, I'm looking at this armor stand and again looking at the rotation in the second entry. So if I activate this one here, now I have the same score. And you can see this score is independent, so I'm not just copying it over or something similar. Yeah. So I can very easily change the score or write a score into NBT data and write NBT data into a score. Very powerful tool because, just as an example, using the local coordinates. Let me quickly turn all of that off again. If you're using local coordinates, you can, for example, teleport an entity 1 meter in front of the armor stand, relative to where the armor stand is looking at. And if you then take the coordinates, or the difference of the coordinates of the armor stand and the entity that was just teleported, you already have cosine and sine. You can more or less directly use this shortcut to calculate the sine and the cosine of a value in degrees, which is something you couldn't do or only hardly do with the basic maths provided by just scoreboard objectives. So this has quite a bit of power. And with that, we have reached the end of this episode about types, variables, and values. I hope you enjoyed this episode, and well, see ya.